Today's topic is development of tooth. Under this topic, development of tooth, we will be seeing the stages of tooth development, the components of the odontogenic apparatus, the hard tissue formation, root formation, and the rest. As we all know, the development of tooth begins very early as 37 days of intrauterine life. It begins by formation of a thick band of epithelium in the corresponding upper and lower jaw. They are called as primary epithelial band. This primary epithelial band proliferates to give rise to two other bands, namely the vestibular lamina and the dental lamina. The dental lamina give rise to the tooth bud, whereas the vestibular lamina soon proliferate and degenerate to give a vestibule or a cleft in the oral cavity. I am sure all of you are aware where the vestibule of the oral cavity is present. So that is formed by degeneration of vestibular lamina. So what happens to the dental lamina? The dental lamina, after formation of tooth, it will also degenerate, but few remnants present. They present occasionally, and they are called as epithelial cell rest or cell rest of Cirrhe. So rare occasions, they may turn into a cyst or a tumor. Around 8th week of intrauterine life, 10 swellings develop in the corresponding deciduous tooth, and this swelling are called as tooth germs, and they are divided into bud, cap, and bell stage based on the morphological appearance for easy understanding. In real, all this happened continuously, seamlessly. There is no stop between the bud and the cap stage. It happens in a continuous manner. Just for understanding, they have typed it into bud stage, cap stage, and bell stage. Bud stage begins as an enamel organ. The tooth germ grows down, proliferates in the connective tissue. It has an outer cuboidal cell and central polygonal cell. The collection of cells present around the enamel organ is called the dental papilla. The dental follicle is the collection of cell which encloses the dental papilla and enamel organ together. Moving on to the cap stage, the next stage, it is named so because of its appearance like a cap with the central invagination. It has an outer enamel epithelium. The inner slightly columnar cells called the inner enamel epithelium, center star-shaped cells called stellate reticulum, and collection of cells in the inner enamel epithelium is called as the enamel knot. As the enamel knot proliferates to the outer enamel epithelium or connect between the inner and outer enamel epithelium of enamel knot is called as the enamel cord, and the cervical loop. Cervical loop is a point where the outer and inner enamel epithelium meets. Usually this is very sharp. Thus, the cap stage has a enamel organ and its component. You know what are those? The outer enamel epithelium, inner enamel epithelium, stellate reticulum. The cervical loop is the connecting point between the outer and inner enamel epithelium, the dental papilla, and the dental follicle. So every stage of tooth development will have an enamel organ, dental papilla, and dental follicle, with few changes happening within the enamel organ. Here you have to remember, in cap stage is formation of enamel knot and enamel cord. Moving on to the next stage, early bell stage. You know why it is called so, because of its appearance of bell-like appearance. So here the enamel organ will have an additional component called as stratum intermedium, which is a flat-shaped cell which is present in between the stellate reticulum cells and the inner enamel epithelial cells. So here the bell stage will have an enamel organ with its component, the dental papilla and the dental sac. One more thing you have to remember here is the presence of membrana performata, which is a strong or a basement membrane which is seen very evidently at this stage, which separates the enamel and the dental papilla very clearly. Moving on to the next stage, the late bell stage. Here all you see is complete development or overall development of the enamel organ is completely almost done. The dental papilla also begins the formation of odontoblast, which is the dentin forming cell. So here in this late bell stage, you will see the formation of hard tissue, the enamel and the dentin, and this process is explained by a term called apposition. So what is apposition? Apposition is nothing but the odontoblast are the cells which forms the dentin, and they are present in the periphery of the dental papilla. The periphery of the dental papilla will differentiate into the peripheral cells of the dental papilla will differentiate or changes itself to an odontoblast. Similarly, the inner enamel epithelium will convert itself into an ameloblast. This picture will show you more clearly. The stages of apposition is typed first in 4 stages. The first stage is elongation of inner enamel epithelial cells. The inner enamel epithelial cell is preparing itself to convert itself into an ameloblast, which is an enamel forming cell. The outer peripheral cells of the dental papilla is preparing itself to convert into an odontoblast. Then there will be a secretion of dentin. Once the dentin is formed, this dentin is going to in turn stimulate the inner enamel epithelium to convert itself into an ameloblast and then synthesis enamel. So this picture clearly shows, I would like you to trace it from the dental papilla. At the periphery of the dental papilla, you are able to see a tall columnar cells which are the odontoblasts, the dentin forming cell, and you can see an yellow dentin. The shaded with the yellow is the layer formed, the dentin layer form. This formed layer dentin will stimulate the inner enamel epithelium to convert itself into an ameloblast, which is an enamel forming cell, and little tiny orange enamel matrix which you see at the cuspal tip is the enamel. So it goes in this order. Surprisingly, you will have to remember that it is the dentin which is formed first and not the enamel. So first there will be formation, preparation of pre-ameloblast. The inner enamel epithelium will get dressed and get ready, and once the odontoblast is formed, this odontoblast is going to secrete the dentin, and the dentin is going to stimulate the enamel organ, the ameloblast, to synthesis enamel. So moving on to the root formation. Root formation is by the Hertzsprung epithelial root sheet. It is nothing but the proliferation of cervical loop. You know what is cervical loop? It is the point where the inner and outer enamel epithelium meets, and there is no central stellate reticulum or stratum intermedium. So it is just the outer and inner enamel epithelium. This Hertzsprung epithelial root sheet will guide the root formation. The Hertzsprung epithelial root sheet will bend at 90 degrees and it will stay there. And as the tooth grows up, just imagine a rocket. So similarly, as the tooth grows up, the root will be forming down. So it is not the Hertzsprung epithelial root sheet which is going down. The Hertzsprung epithelial root sheet will remain at the same level wherein the tooth grows. As the tooth grows, the root will keep forming. So what happens is the Hertzsprung epithelial root sheet will come in contact with the dental papilla, and this dental papilla will secrete the dentin matrix. And this dentin matrix, I told you, the Hertzsprung epithelial root sheet will also break down and gets washed off. Those are called as cell rest of Malassez. So I would like to give a summary. Tooth germ includes three main apparatus: the enamel organ, the dental papilla, and the dental follicle. The enamel organ and its component give rise to enamel. Dental papilla and its component give rise to dentin and pulp. The dental follicle is responsible for formation of the supporting structures, namely cementum, periodontal ligament, and alveolar bone. So that's the component of the tooth germ. Together it is called as odontogenic apparatus. So with that, we would like to conclude this class. Thank you very much.